Okay, let's take a look at the input predictor class that implements the Oracle's algorithm. Basically, we can divide this script into 4 parts. The prepare script part, prepare the algorithm part, so create all the sequences and fill in the data. The prediction part, how we predict the input, and the get accuracy part, the way we check the accuracy to how to calculate the valid mean. Let's start with preparation of the class. We have sequence ready. It was used when the player first provided input. We calculate what is the positive and negative input. So for example, if this is horizontal, we get value on x-axis. If it is vertical, on y-axis. Next, we have a linked list that will store recent inputs. As we have previously discussed, this will be a list of 5 previous inputs that will be used to find the sequence that is the same as those inputs. And for this sequence, we will be checking if the next prediction should be either positive or negative input. The sequences will be stored in the dictionary as a sequence will be the key and input type class will be the value. Input type class, let me find it, is just simply positive and negative integer. Here we store how many positive and how many negative inputs did the player give for this particular sequence, and those two values will be used for predicting the future input. So having prepared the class, let's see how to prepare the algorithm. This is the prepare the predictor class method. It will take input as its argument. If the user provides horizontal or vertical input, we will set the positive and negative input accordingly. So we have this algorithm is universal and we don't need to worry about it. Next, we fill in the recent inputs list with random values based on the inputs. We could also provide the predicted input for the first few times by giving away a random value. So we could instead of filling in the linked list, we could just provide random input as the predicted input until we have the 5 inputs from the player. But this is the way I have done it. Next, we create the sequence list. And the sequence all the sequences will be stored as a list of vector 3s in a list. So this list will contain 32 lists of vector 3s, and those will be sequences. Let's go to the method. Here it is. And it first of all creates a list of possible values. So for us, it will be a positive or negative input. Here we just take the input straight from the value that was provided to prepare the prediction class method. But you could also just take the positive and negative values that we store at the top. Now, we get the variation with repetition. That is what I've described in the theoretical introduction to this problem, this algorithm. So let's go to this implementation. Basically, it uses recursive call out the method. So we call the same method every time based on the input. So the list we have created here, we have only 2 inputs, and we give 5, as we have discussed that we take the sequence of 5 inputs to predict the next input. And basically all it does is for each item in the input item, it creates each sequence of unique inputs that could be given by the player, and every time it calls itself again, it calls itself with length -1 to achieve that goal. Basically, it returns us 32 unique sequences of 5 inputs. Having that all, you can observe that it is enumerable of enumerables with a generic type. This allows you to input whatever you need to, not necessarily vector 3. Now, going back to the creation, because it is a generic type, we need to convert it to the list of vector 3s. So this is what we are doing here. We're looping for with each enumerable. They create a new list, add all the elements to this list, and add the list to the all sequence list. And that's how we create a list of lists that contains the 32 sequences. And we return all the sequences and save them as the list. And next, we fill in prediction model dictionary. So we had at the top the dictionary that contains key, the sequence, and value as the input type class, so positive and negative count. We store this in the dictionary for easily accessing, to easily access the input type class. So this is the part when we have prepared the algorithm. We call the sequence ready true, and we are ready to give away predictions for the future inputs. Now, having the algorithm ready and set up to give out predictions, we move to the prediction logic. So to predict input, we need to acquire a new input. We set temp prediction to positive input, whether it is up arrow or right arrow. Next, we need to know that the linked list contains 5 predictions. Now, if you wouldn't provide a random values in the preparation step, here would be the place where if you don't have 5 inputs on your list, you add the input and return the random value. Currently, we do not have this issue because we have given the random values as recent inputs. Next, we acquire the instance of the input type class for the prediction that was recent. So for the first step, it is just the sequence for our random values, but for each next step, we will get closer to what the user inputs and what is his pattern. So at the start, the Oracle's algorithm doesn't give valid predictions. It needs some time to acquire the accuracy that is high. At the beginning, you are oscillating about 50% or lower, but with more predictions, you get higher scores. After acquiring this, we can update the model. So let's go to that. So having the recent input, we know that what was the last prediction, but it doesn't concern us here. We always want to update the model. And I have tried updating the model only when the prediction was false, but apparently the more data that you get, the more accurate the algorithm is. So we take each input and we append the 1 to the value of positive or negative values, depending on what the user inputted in that sequence. After updating the sequence, and of course we add it to the prediction results. Prediction results, I have not mentioned maybe, it is a list of Boolean values, and it will be useful when we calculate the mean. For now, we just add each prediction as a success, so true or false, so the prediction was incorrect, to the list. And the list will store all the predictions and how they did with the actual input. So that's out of the way. Let's go back to the prediction code. Here it is. So we update the model after each input from the user. Having the newest input, we can remove the last element, the first element from the sequence that was previous, and add the current input as the last element of the sequence. So having updated the sequence, we yet again get the input type class for the current sequence with the new input. And because we have the input type class, we know whether for this sequence more inputs are positive or negative. So does the user more frequently puts a right arrow or up, or left arrow or down? And we have to account for the case where positive and negative inputs are the same. In this case, we need to return something. I am currently returning positive input whether the positive is greater or the sequence, the values are equal, and the negative when the negative are more frequent. And having the new predicted value, we simply return it in this step. So each time user enters an input, we can predict new input. But we can predict only one input, so only one step ahead. So this is the limitation of this algorithm. And of course, we strongly rely that the user is quite unaware that he is making patterns. I have read that many people, when they consciously tried to change the pattern, they could acquire or they could make the algorithm have less accuracy because they were constantly consciously changing the pattern. So this is the limitation of the algorithm. You need to make sure that the user is unaware of the algorithm, or he will figure it out and get the low scores for the accuracy of the algorithm. So one of the last step is to get accuracy. After predicting the values, we would like to know how accurate the algorithm is. To calculate it, we use a mean value, but we don't calculate the mean value for every prediction that we have made for all the playing time, because we would start to oscillate around 50%. This is why we take the mean max values, which is 50. So we are taking only last 50 predictions to the calculations of the mean. And this is my version. I have checked it out against the algorithm from the Aaronson site, and it seems to give a similar values for the mean. But this step, I am not quite sure if it happens like this. I know that they are also calculating the mean from the most recent values, not from all values. So that's why we take the 50 most recent values. Here we take the list from prediction results and take only the 50 values if we have more values on the list. We are using a link library. We are importing using system.link. On the other hand, if the prediction count is less than 50, we just take all the values that we have available and return the mean. So that's it. That's how the algorithm works. In a community game jam entry, me and some guys I was grouped with through CrowdForge have created a game that uses the algorithm. Let's see how it is used here. So in this game you are a wolf in a sheep's skin, and your goal is to get a sheep. It's a little rough game. Let's see, we can fight this wolf. So if we input random Z and X combinations, we can win or lose. You can see that I have inputted less random, more pattern-like combination, and I went to the red zone and lost. Okay, so that's it for Oracle's algorithm in Unity. I hope you have enjoyed this tutorial. If you did, please like and subscribe, and if I have helped you, maybe consider supporting me on Patreon. I provided all the links below. Thank you for watching. Goodbye.